Hello, everybody, and welcome to the June edition of the Virtual Planetarium with Pete Lawrence and me, Paul Abel. And as ever, we will start with our inner solar system. But the situation with regards to planets in general is quite different. So towards the end of 2024 and in early 2025, there were planets all through the night sky. And unfortunately, that's really not the case now, is it? There's a real shortage of them.
You had a planet parade, Paul.
A planetary parade, yes. I mean, surely you get that anytime there's a few planets in the night sky. So
They are all in a line on the ecliptic, and it was quite difficult to see some of them.
Well, yeah, some of them were very close to the sun. But, OK, well, let's start with Mercury. Unfortunately, the inner member of the solar system continuing to flick back either side of the sun. It's on the eastern side or on the evening side of the sun this month, but you'll need a flat horizon to see it because it is quite
It's not well placed, is it? Right at the beginning of the month, but on the 8th of June. At magnitude minus 1.1, it'll sit just 2 degrees from mag minus 1.8 Jupiter, but the pair set about an hour after sunset. So that makes spotting them a little bit difficult, really.
Yes.
So that's not bad. It's a good challenge thing to go for if you've got a good clear horizon. But do wait until the sun has set before you do try. Now, by the 15th of June, Mercury will have faded to about magnitude minus 0.5, but it will have sufficiently moved from the sun to set 90 minutes after sunset. And that, coupled with it holding on to some of its former brightness, should make it a more viable target, I think.
Yeah, as the month progresses, Mercury continues to move away from the sun, but it also continues to lose brightness. So on the 26th and 27th of June, it's a good time to look because there'll be a waxing crescent moon, which moves from right to left of Mercury, which will be about magnitude plus 0.2 then. So, so some opportunities for there. Much more striking, although in the morning sky rather than the evening, is the planet Venus. It rises just before 0330 BST, so 2:30 UT on the 1st of June, with sunrise is just before 0500 BST or 0400 UT. So there's a 40-minute window to try and catch the planet, but it is very bright. I find it best to observe the planet during the day because this really reduces the glare from the surface, from the brilliant clouds that cover Venus. So but it is worth having a look at still. It's coming up to dichotomy this month, isn't it? So
yes, it reaches its greatest western elongation on the 1st of June. It'll be separated from the sun by about 45.9 degrees if you want to be technical about it, and it'll be 23 arc seconds across. Of course, you get the phase anomaly, which means that in the morning sky the 50% phase in theory should be late.
Yes.
From what is predicted geometrically. Do you want to be controversial?
No, you do the controversial bit because you claim to have imaged it, not me. Well, so just before I drop you in it and run, you go first, and then I'll say what I thought. Go on.
Okay. Well, I think Venus is a difficult planet because it's incredibly bright. Okay, yeah. And it's a planet which shows a lot of optical anomalies. I mean, we've had things in the past like the black drop when you have a Venus transit, which was shown not to be real. You've got the ashen light.
We're not going through that. We're not going through that again.
And then you've got the dichotomy or the phase anomaly, which has been observed a lot, admittedly, over many hundreds of years.
Yeah.
But if you actually image Venus and you push the gamma up so you can see the terminator properly, it does look as if the phase anomaly isn't quite as pronounced as you would expect it to be. So there is illumination right the way up to the terminator that gives you the 50% when it should be there.
Yeah, I think certainly from a visual point of view.
Oh, visually, it's really difficult to see that because the drop-off is almost asymptotic.
It is and it isn't to an extent. So the phase anomaly is much more obvious when you use the full aperture. So if I observe Venus with the with my 12-inch or do the 8-inch telescope, the phase anomaly is there. If I stop the aperture down to 40, 50 millimeters, then the observed phase is very similar to the theoretical. They're not quite the same, but they are very close. So I wonder whether in stopping down the aperture, you're having much less light flooding things, and the fall off, because you get that terminator shading near the terminator, is much more gradual. So I think that might be why the phase anomaly is less pronounced in very, very small instruments rather than it's much more obvious in larger ones.
Well, if you're a planetary observer or imager, have a look and see what you think, and you can send your results into the magazine.
Yes, we'd be most interested to hear not just images as well, some visual observations. In actual fact, estimating dichotomy visually is really tricky, because even in average seeing, the terminator between 49, 50 and 51% is practically the same. So it is really challenging to do visually. I'd recommend putting on a yellow filter, because that seems to sharpen the edge of the terminator and makes it a bit easier. I also take out a printed chart which has the phase of 50, 49, 48 and 51, so I can compare it and see which one I think is more realistic.
It's good. And also they can send them to you, I guess.
Yes, that's right. It'd be most
because you are
interesting.
the director of the British Astronomical Association Mercury and Venus section.
That's right. Yes. So it is an interesting thing to keep, because there's still lots of mysteries with Venus that haven't quite been sewn up yet. So
which is what I love about the planet.
Yeah, that's right. So all this nonsense that it's a bland planet is absolutely for the birds. It's a fascinating planet with lots of interesting things to see. And actually, I should just mention, whilst on the subject of Venus, on the 22nd of June, 15% lit waning crescent moon lies 5.9 degrees north of Venus. So that'd be quite a nice
That'll
thing
be
to
lovely.
see, providing the sky is clear. Moving on then, next planet out, which is challenging for a whole host of different reasons. The planet Mars. Oh, it's lingering.
Yay.
It's lingering. It's
in its lingering phase, isn't it?
And the lingering phase lasts about half a year, doesn't it?
Well, and just to explain what this is, as everything drifts westward really slowly from one day to the next, everything sort of drifts to the west. But Mars, at this point after opposition, has a fairly good motion to the east, so it counteracts the westward motion. So it basically appears to stay almost in the same position relative to the horizon, and it just hangs about forever.
Getting smaller and fainter, and it's really, there's not much you can do. I guess images you're okay, but with visual work it is getting quite challenging to see anything on there now. I mean, I think just at the start of June, it's about 5 arc seconds across, so you really will need a large telescope to see much on the surface.
There is an interesting thing happening with Mars. Between the 15th and the 18th of June, it makes a really close pass of Regulus.
Okay.
It's just 52 arc minutes from the star, and you should be able to see it in deep twilight. So that'll be quite a nice meeting, actually.
Yes, absolutely. Okay, well,
a similar brightness as well.
They are, but very different. Actually, it's probably quite hard to tell the colour of Mars if it's in a bright twilight sky, because that orange colour is going to be lost, isn't it?
Yes, it would.
Yeah. Okay. All right. Next planet out, planet Jupiter. Well, not really visible, is it? I mean, it's lost to the evening twilight now, so not really helpful. Saturn placed in the morning sky, but again, not really in a good position at the start of the month.
No.
We're getting to the edgewise presentation of the rings now, but I think we're going to have to wait a couple more months before Saturn clears a bit further away from the sun, so that we can see anything useful.
Okay, well, Saturn is very close to Neptune, so that should answer the question whether Neptune is visible, because Neptune is not really a viable target, and I've missed out Uranus. I'll pick this one up, Paul. It's not visible.
You take all the strain in these VPs, don't you? All right, we have some specials this month. Actually, we have some nice specials. Of course, noctilucent cloud season is the most important thing, because it's now upon us. So June and July are the best months of the year, really, to spot these high-altitude clouds right on the near edge of space, actually. So will we get we don't know whether we'll get good displays or not. Some years are better than others.
They are indeed, yes. We've had last year, 2024, had some quite good displays with it. It's difficult. What I like about noctilucent clouds, or what I dislike about them at the same time, I guess, is the fact that from where I'm conflicted all the time. Where I am located, I can't really see the location to the north and the northeast from my house. So you often get that pull to say, right, you've got to go outside and wander away a bit, so you've got a good location so you can actually check them. So you're constantly, if you're tired, you're constantly convincing yourself, no, I'm sure they're not there. But of course, whenever you're like that, and you do actually make the effort and go, they are there.
Yeah.
And a lot of people, I think, miss them. There was a big display a few years back, and I can remember putting it up on social media saying, get out there now, have a look at noctilucent clouds. And people were saying, I can't see them, they're not there. And the reason for that is because they were low.
Yeah.
And you've got to have a really good, clear horizon. They're not always low. Sometimes they do get quite high. And there are observations, I've made observations in the past, where as you go through into the morning, they appear to get quite high altitude above the horizon. From Selsey, where I used to live, I have seen them go virtually overhead and down towards the south as the sun is getting higher. And there were definitely noctilucent clouds because they disappeared as the brightness of the twilight got to a certain point. So these are really interesting observations to make. Don't just go outside and take a picture and say, oh, look what I've taken a picture of. Actually take a picture and keep going as long as you can. Try to make sure you get a star or two in the shot if you're taking photographs. If you're doing it visually, record the position of the star relative to the edge of the noctilucent clouds. And that way, so long as you record your date, time and location, you can work out what their altitude is. And that's really important.
And the other thing as well is in a series of images, photographs, you actually can see the structure of the clouds changing. They're quite they're quite dynamic. So definitely one to watch out for. And of course requires no expensive equipment whatsoever.
No, the only thing you need to do is go out typically 90 to 120 minutes after the sun has set and look low above the northwest horizon, typically, although that's not always the case, and a similar time before sunrise in the morning. So basically, if you get into the habit, the night isn't very long at this time of year, so you can get into the habit of checking in the evening and then checking in the morning, then you can go to bed.
Yeah, especially if there's no planets to do.
No, that's true.
Okay, well, what else have we got this month then? Well, on the 4th of June, there's an effect known as Pluto's Hook, which is visible on the evening moon. It's best around 2300 BST, so 10 o'clock in the evening UT, where this time a curious rim peak shadow can be seen, which appears to curve slightly. I have to say, I have looked for this many times, and it has never looked curved to me.
Yes, we should explain this is in the crater Plato, which has got a really flat lava smooth floor. And
in fact, it's an unusual crater. It looks more like a walled plain, really. But it's very smooth.
It always looks like a
floor.
swimming pool on the northern edge of the Mare Imbrium to me.
Yes, yes.
So basically, on the eastern rim, you've got what's called the Gamma Peak, and this casts a pointed, like a shark's tooth shadow across the floor. And it was reported by a friend of ours, wasn't it?
It was, Patrick. I've seen his notebook with the drawing in.
Right.
He saw it a couple of times. I think he saw it once at Murdon, actually.
That's right,
if I'm not mistaken. And he was absolutely sure that there was this curvature to the shadow. But I've never seen that. I don't know whether he had some combination of the libration and shadow and lighting was just right to make it look curved, or whether it was because he was using a very large telescope. I honestly have no idea.
Now, that's an interesting point because I've looked at this quite a lot, and there is it's like a scree area on the inner part of the rim on the southeast edge. So it's like a load of loose rocks which have spread across the floor. And if you get the shadow in the right position, you could almost get it so it sort of hits that. scree area, and it would give an impression of curvature. I've never seen it, I've never imaged it, but I'm quite interested to see whether it is possible to grab that.
Yeah, I don't think he saw it that often. It's quite a long time ago now, but I think I only saw a drawing in his notebook of it, and it was with the large Murdon refractor. I don't think it was something he saw every lunation. I mean, he observed.
No, he wasn't looking for that, was it?
No,
it was just it was a last minute thing they noticed.
Yeah.
It was him and Percy Wilkins.
That's right.
Wasn't it,
Yeah,
at the time?
that's right. Yeah.
And they just made a note of it and said it looked curved.
Yeah.
And of course, it's become this controversial anomaly ever since, which is great. I mean, that's what's exciting about observing the moon.
So let's have a look on the 4th of June. Hopefully it will be clear, and we'll see if we can see any curvature to the shadow.
Yeah. Well, we've also got with the moon, we've got this an interesting effect at the moment. We've got a major lunar standstill. I think that occurred last January, and this is basically because the moon's orbit is tilted to the orbit of the Earth by 5 degrees. There are conditions where the moon can be at an extreme low declination or an extreme high declination. And the full moon in June is in a part of the sky, which is Sagittarius area, which means it's going to be quite low anyway, because the ecliptic is low at that time. And because of this recent major lunar standstill, it means that the full moon is going to be really low down above the horizon.
Right.
I think it barely creeps up above 10 degrees at the south point, which means that you can see the full moon really low down for a long time, which gives you a great opportunity to experience the moon illusion.
Yeah, which is a very real illusion.
Oh, it is.
I have to say, I've tried to remove it by sort of covering up. If you cover up with your hand houses and things nearby, it still doesn't seem to reduce it. So it is something about it appearing very low down, and it does look. I suppose also it looks very, very striking, doesn't it? A full moon low down. Is quite a sight.
I mean, I've been doing astronomy for a few years now, and
centuries.
Always with the insults. I have seen the moon. I don't actively tend to go out and look for the full moon just coming up above the horizon, but I have caught it quite a number of times, and I'm always taken aback by how large it looks.
Yeah.
It just looks absolutely vast, and it isn't any bigger than normal.
No.
If you hold your little finger out at arm's length, it'll easily cover it.
But it is quite striking. It often it makes you jump, doesn't it? If you forget the full moon is about to rise, you notice it very low down. It is.
Well, I'm not that nervous.
It
but
takes you by surprise. Whoa,
the moon illusion.
Pointing at the moon.
What's going on?
All right, what else do we have? Well, on 21st, the sun reaches its most northerly declination against the background stars. So this marks the point in time known as the summer solstice. I should say, qualify that. In the northern hemisphere, it is the summer solstice, but for people in the southern hemisphere, that is the winter solstice.
Yes, and in the Northern Hemisphere, at precisely that time, at 03:42 BST, that's when you can be annoying and say, winter draws on.
Oh, don't, for heaven's sake. Okay, and on the 22nd, a tricky observation, that's very, very tricky, this morning 7% lit waning crescent moon will clip the southernmost stars of the Pleiades open cluster. Now, this event will be in bright twilight, so that's quite a challenge, isn't it?
It is. There are a couple more of these coming up later on in the year, because the moon is in that position at the moment where it's able to interact with the Pleiades. They are amazing events to watch if you get opportunity. We had one in March, I think it was, and it was just glorious to watch the moon creep through the open cluster, hiding the stars. And what I love about it is when you get a bright star going behind the moon, because the moon's edge is like a razor sharp. There's no atmosphere on the moon, and the star's light is a pinpoint of light, very distant, obviously. But as that light comes through our atmosphere, the atmosphere blurs it into a fuzzy disk, so the star appears to actually have a tangible size. So if you're watching it through a telescope, you see this fuzzy disk and you think as the moon hits it, it's just going to fade away to nothing. But it doesn't. It just turns off. Yeah,
it's quite something. I haven't seen an occultation of a star by the moon for some time, but they are quite striking. As you say, if they're bright stars in particular, they're quite interesting to watch.
Yeah. Okay. Well, let's go out into the night sky now. And the old saying, follow the arc to Arcturus, follow the arc of the handle of the saucepan away from the pan. You'll come to the brilliant orange star Arcturus, which is the brightest star in the northern celestial hemisphere, the brightest nighttime star in the northern celestial hemisphere.
So every time you mention it, you just qualify it with this pointless. It's such a meaningless thing to
Somebody
say.
will write in, Paul. Somebody will write in.
Yes, you.
Pete Lawrence
probably.
is talking rubbish.
Well, that's not a surprise to anybody, so no one will write in, do they? But it is. I tell you what, though, there are some nice double stars in Borealis, which is
Yes, there are.
the primary constellation, and there's also some nice variable stars, and I'm going to give a little shout out to V Bootis, which is a very nice red giant star. It slowly pulsates and has a nice regular light curve with some unusual, interesting features to it. So it's a good time of year to, even though the planets aren't about, to think about observing other things.
Well, there's another very famous variable star near Arcturus, isn't there, which is the blaze star, T Corona Borealis.
Which has refused to blaze so far. We're recording this in April. I made an observation of it last week. It's still at magnitude 10.1. Refuses to get any brighter. So
Refuses to get any brighter. There have been some interesting predictions. There was a prediction recently that actually named the day it was going to get brighter, which
yes,
is
it was terribly brave. That wasn't it. It's
I
like
thought
naming
so.
the day of the apocalypse, isn't it?
But it was.
'Cause
Yeah, but it wasn't. There wasn't madness with it. It was actually a very good observation. It was based on the number of orbits which are likely to cause it. So, in science, if you make that prediction and you rule it out, you've ruled out one particular scenario, which is how
Yes.
science should work, of course.
Yes. So that's one of the models is probably not sufficient to explain it. So we should explain that T Corona Borealis, the blaze star, it goes through this brightening because it's a red giant with a heavy compact star, and so it's a binary system, and the heavy star draws off the material off the red giant, and it explodes periodically, but it doesn't happen that often, and we've kind of been waiting for it to happen now for a couple of years, and it's still not occurred. So in a way, that's more interesting than if it had gone off with all the predictions. It sort of makes it means that there's a lot of guesswork still to be, a lot of model filling to have with astrophysics of these kinds of stars, I think.
The most dangerous thing, I think, in any science is just assuming that you know what's happening and you know everything. So this is good because it proves that we don't know what's happening.
Absolutely.
And we're learning from it. Another star, actually, which is a star of summer, which is also orange, we were talking about Arcturus, is Antares, which is the brightest star in Scorpius. And you were talking about the doubles in Borealis. Well, Antares is a double, isn't it?
It is. So this is interesting because you don't need a very large telescope because the separation between the two stars is actually quite wide. But it does look slightly greenish, the secondary star with Antares. And I think it's because Antares is so red.
It's regarded as quite a difficult thing to see, this one, because I know it's 2.6 arc seconds apart and the companion is mag 5.4, but it's the fact that it's low down and you often get poor seeing.
Or mist and clouds, actually, as well. That can really hamper it. So it does need you do need a clear horizon, and you do, as you say, need the good seeing to be able to see it. But the colour difference is quite striking, I think.
Yeah, and it does have a definite greenish hue to it compared to the orange of Antares.
And we should mention that very near to Antares is a rather lovely, often overlooked globular cluster, Messier 4, which I think is quite a lovely cluster to look at.
If that were higher in the sky, that would be quite an amazing object from the UK.
Yeah, it would, wouldn't it? It's a shame it's rather lost in the midst of the murk. So it's 7,000 light years away, so it is quite a way. But it does look like a glorious cluster. Yeah, as you're right. I imagine if you live down south, then this would be quite a nice target to see quite frequently in summer.
Yeah, well, as we're going into summer, of course, we've got a hint of the summer constellations with the huge asterism known as the Summer Triangle. And the Summer Triangle is made up of Deneb, Vega, and Altair. Now, Deneb is the brightest star in Cygnus the Swan, and there is the Milky Way runs down the vertical of the what's called the Northern Cross, which is a pattern in the centre of Cygnus. That's quite an interesting area to look at because you get a lot of dark dust lanes running down there. You get what's known as the Cygnus Rift, which is running down the main vertical of the constellation, if you like. But there are a couple of others there, which I don't know how familiar you are with these, Paul. You've got the Northern Coal Sack, which is near to Deneb.
Yeah, I'm familiar with it. I haven't actually seen it. I have seen the North American nebula, NGC 7000, but...
which is a bright nebula. Yeah, the Coal Sack is a dark one, about 5 degrees across. It's that void next to Deneb. But the other one, which is quite interesting, is around the star Eta Cygni, which is called the fish on a platter. It's Barnard 144, and it's sort of this elongated elliptical dark patch, which I've never seen that. I'm going to go and try and find that this year.
Yeah, I've never seen the fish on a platter. Is it actually have any resemblance to a fish on a platter, or is it just a bit of a splodge that's got some curvature to it? I've never seen an image of it either.
I think if you've got a good imagination, as you have to have it in astronomy, you could probably think that there was a fish on a platter there. Okay, well, we better wrap up. But before we go this month, just a quick shout out to the constellation of Cassiopeia, the seated queen, because that is often described as the celestial W, and at this time of year it lives up to its name because the W is the right way round in the evening sky.
It is indeed. When it's on its side, it looks more like the Greek letter capital Sigma.
Yes, it does.
The celestial Sigma and the celestial W from time to time. Okay, well, I hope everyone gets some clear skies and gets a chance to look at some of the objects in the night skies we've discussed. So thanks, Pete.
Thank you, Paul.